Every time a new AI model comes out, one of the first things anyone mentions is the context window. It went from 4K to 32K to 200K tokens. Now some are claiming a million, and the announcement always lands like a pure upgrade, like a bigger number is just better, full stop. But I have been working with these models long enough that I want to slow that down, because the number alone does not tell you much. A bigger context window changes what is possible, yes, but it also changes what it costs, how fast it responds, and quietly it changes how well the model actually uses what you gave it. So let me explain what a context window actually is in plain terms, and then let me tell you honestly why bigger is not the clean win the launch announcements make it sound like. What a context window actually is. The simplest way I know to describe a context window is working memory. When you sit down with a problem, there is only so much you can hold in your head at once. You might have a 20-page document in front of you, but you are really only thinking about a few paragraphs at any given moment. A language model works the same way, but with one important difference. The model can only work with what is inside its context window right now. Everything outside that window does not exist to the model. It is not in the background somewhere. It is gone until you put it back. The context window is the total space for everything the model can see at once. Your instructions, the conversation so far, any documents you pasted in, and the answer it is building. All of it competes for that same fixed space. Tokens are the unit everything is measured in. The context window is measured in tokens, not words, not characters, not pages. So it is worth knowing what a token actually is, because the number only makes sense if you understand the unit. A token is roughly a chunk of a word, not a whole word, not a letter, something in between. A short common word like the is usually one token. A longer or less common word might split into 2 or 3. On average, across normal English prose, one token is somewhere around 3 to 4 characters, which works out to roughly 75 words per 100 tokens. So when someone says a model has a 128K context window, that is roughly 96,000 words, or about 2 full-length novels side by side. That is the working memory the model gets to look at all at once. Tokens also matter because they are how you get billed. Every token going in and every token coming out has a cost. The size of the context is not just a technical spec. It is directly tied to what each call costs you. Why a bigger context window sounds great. With that frame, it is easy to see why a bigger context window is genuinely exciting on paper. It means you can hand the model a whole long document and ask questions about any part of it without having to figure out which pages to include. It means a long conversation can keep its full history without you needing to worry about things falling off the edge. For coding, it means you can drop in a large code base and ask the model to reason about how pieces connect. For writing, it means you can paste in everything you have written so far and ask for help being consistent. These are real improvements. Tasks that used to require careful engineering to even attempt now just work with a long enough context. I am not pretending the bigger number is meaningless. It genuinely unlocked things that were not practical before, but it also introduced a set of problems that do not show up in the launch post. The cost problem is real and compounds fast. The first thing a bigger context window changes, and the thing most people underestimate, is cost. Because tokens are the unit you pay for. Every single call you make with a large context is expensive relative to a smaller one. And it is not just the input tokens you are paying for. Many providers charge separately for output tokens too, and the big context is the input side. If you are building something that makes dozens of calls a day with a 100K token context on every call, the math adds up fast. And this is not an argument against ever using large contexts. Sometimes the task genuinely needs it. But it does mean you should not just leave a massive context open by default because you can. I have worked with people who fill their context with everything they might possibly need, every time, and then wondered why their API bills looked the way they did. Bigger context should be a deliberate choice, not a default setting. Latency goes up with context length. The second thing that gets worse with a bigger context is speed. More tokens in the context means more work for the model, and that translates directly to longer response times. On a short prompt with a tight context, a capable model can respond in a second or 2. Fill that same model's context with 100 pages of material, and you might be waiting many seconds for the first token to appear. For a quick back-and-forth conversation that is annoying. For an automated pipeline that runs hundreds of calls per day, it compounds into a serious slowdown. Some providers have made progress on this with better hardware and smarter attention mechanisms, but the physics have not changed. More to process still means more time. The speed cost is often invisible in demos, because you run it once and it seems fine. In production at volume, you notice it. The lost in the middle problem is the most important one. And here is the problem I think matters most, and the one that gets talked about the least. Models do not pay equal attention to everything in their context. Research has shown, and my own experience confirms this, that models tend to do better with information that is near the beginning or the end of the context, and worse with things buried in the middle. This is called lost in the middle, and it is a real, documented failure mode. You can paste in a 50-page report, ask the model a question that is answered clearly on page 27, and get a confidently wrong answer because the relevant passage was in the middle of a huge context. The model read everything, technically, but it did not weigh everything equally. So the naive assumption that more context equals better answers breaks down here. If the thing the model needs to actually answer your question correctly is sitting in the middle of a very long context, there is a meaningful chance it gets underweighted or missed. A well-chosen short context often beats a sprawling long one. Yaminadan Vida, Chenpireshti context in my own work. So with all that, here's how I actually handle context in practice, because having good habits here makes a real difference to both quality and cost. The first habit is to summarize aggressively. Instead of carrying the full conversation history forward into every new call, I keep a running summary of the key decisions and facts from earlier in the session, and I include that summary instead of the raw history. It is denser, cheaper, and avoids the lost in the middle problem for things I actually care about. The second habit is retrieval over stuffing. If I have a large document collection, I do not paste all of it in. I find the few passages that are actually relevant to the current question and include only those. Retrieval augmented generation is the formal name for this pattern, but the intuition is simple. Fetch what matters, leave the rest out. The third habit is to prune before each call. I look at what is in the context and I ask what of this is actually needed right now. Anything that was useful 2 steps ago but is not relevant to the current question gets trimmed. It takes a few extra seconds and it consistently makes the answers better. Summarizing is cheaper than you think. On the summarization point, I want to say a bit more because people often resist it under the assumption that you lose information when you summarize. And you do lose some information, that is true, but consider what you are trading it for. A tight summary of a long conversation is much cheaper to include in every call, much faster to process, and much less likely to bury the key point in the middle of a sea of tokens. Yes, you lose some detail. In practice, the detail you lose is usually the kind that would have gotten lost in the middle of a long context anyway. The high-value stuff, the decisions, the constraints, the things you keep referring back to, that is exactly what a good summary captures. I would rather have a well-compressed summary of what matters than a full transcript that the model will weight unevenly. The compression is not a cost. Most of the time it is a net improvement. Retrieval is often better than stuffing. The same logic applies to document retrieval. If you have a large knowledge base and you need the model to answer a question about it, the temptation is to paste in as much as possible. But a smarter approach is to search the knowledge base first, find the 5 or 10 passages that are most relevant to the specific question, and give the model only those. The model can then focus its attention on the material that actually matters. And because you have made the context short and well targeted, you avoid the cost, latency, and lost in the middle problems all at once. The trade-off is that you need a retrieval step which takes a little engineering to set up. But once it is running, it is almost always better than the brute force approach. The model's answers are more reliable, the calls are faster, and the cost per call drops significantly. What giant context numbers are actually telling you? So when you see a model announced with a 2 million token context window, what is that actually telling you? It means you could, in theory, load roughly 1.5 million words of material and ask the model to reason over all of it in a single call. And there are specific tasks where that capability is genuinely useful. Going through a very long code base to find patterns, analyzing a year's worth of documents in one shot, understanding a book-length body of research. But for most of the everyday things people actually use these models for, a million token context is not what changes the quality of the answer. What changes the quality of the answer is giving the model the right information, well organized, focused on the current question, and positioned where the model will actually attend to it. The giant number is a ceiling, not a strategy. It tells you the maximum. It does not tell you the optimal. The honest take on context window claims. I will say one more honest thing about how context window numbers get used in model announcements. They are almost always the best case number, the theoretical maximum under ideal conditions. Real-world effective context, meaning the window over which the model maintains reliable reasoning and does not start losing things in the middle, is usually shorter. Some providers publish benchmark results on long context tasks, and those results can be revealing. A model might claim a 200K context window, but show meaningful degradation in retrieval accuracy beyond 50K tokens. That gap between what the spec says and what the benchmark shows is the thing worth paying attention to. I look for those long context benchmarks now whenever a new model comes out, because the headline number without a benchmark behind it is not telling me much. The question is not how long the context can be. The question is how well the model uses it at the lengths I actually need. The size is a capability, not a guarantee. To put all of this together, the way I think about context windows now is as a ceiling on capability, not a guarantee of quality. A larger context window gives you more options. It lets you attempt tasks that a smaller window could not handle at all. But having the option available does not mean using the maximum is always the right call. For most things I do, a well-managed short context with the right information in it beats a massive context stuffed with everything I might need. The model pays more even attention to a shorter, focused context. It is cheaper, it is faster, and the answers are more reliable. I use large context when the task genuinely needs them, and I manage them carefully even then. The goal is not to fill the context. The goal is to put the right things in front of the model at the right moment. So the next time a model launches, and the announcement leads with the context window size, you know how to read that. It is a ceiling, not a guarantee. It changes what is possible, but it does not change how well the model uses what you give it. The useful questions are whether the model maintains quality across that whole window, what the cost and latency look like at the lengths you actually need, and whether your use case genuinely requires it, or whether a well-managed shorter context would do the job just as well or better. Those are the questions I ask now, and they cut through the launch hype pretty cleanly. If you want more of this kind of grounded breakdown, where I try to actually explain how this stuff works and what it means in practice, subscribe and follow along. Thanks for watching, and I will see you in the next one.